All right, so number one, it said to make a table of values, sketch the graph of the equation. So I literally just plugged in points, like -1, 0, and 1, and you would have gotten 0, 1, and 0. If you remember your transformations as a parabola, the negative makes it face downward, okay? And it's a shift up 1, so that's consistent with what we ended up drawing. Numbers 2 and 3 said to find the x and y intercepts. So for the x-intercept, which is in the blue, well, the work's in the blue, you plug 0 in for y, and you get 0 equals x squared minus 9. Now, you have two choices here. One is add the 9, which is on the left here. Add the 9, and then square root both sides, but you got to make sure you do that plus and minus. The other thing you can do is actually factor that because that's the difference of two squares. So that becomes x plus 3 and x minus 3, and then solve both, and you get -3 and 3. So there's two x-intercepts. And then your y-intercept, you plug 0 in for x, and you get -9. So remember, the intercepts are going to go in coordinate point form. X should have been -3, 0, and 3, 0, and then the y, this is kind of hard to read, but is 0, -9. Questions on that one? All right, and then the last one said a test for symmetry. So for my x-axis test, we're going to plug -y in. It doesn't go back to the original, and it doesn't all change, so it fails that one. Plug in, excuse me, thank you, -x for the y-axis symmetry. And on the -x to the third, it changes that to -x. The positive 10 times -x becomes minus 10x. So part of them change signs, but part of them did not, which means it fails the y-axis symmetry. But then the origin, where we change both, we change the y to -y and the x to -x. This time, every single sign changed sign. Every single sign changed signs. So that this is opposite from my original, and that's the one that passes. So this would be symmetric to the origin. Whatever happens in the top right would reflect down bottom left. How'd we do? Good? Questions on anything of the warm-up? All right, we're going to do a class kick. So I want you to go to class kick, and I'm going to give you a class code. When it asks you for your name, please type in your first and your last name so that you always remember you did first and last, so every time you go in, you get the same name. Otherwise, it generates an extra person every time. All right, I'm going to go over it, but before I do, I just wanted to point something out to you. So I would say probably the hardest part in this classroom is that there's going to be a mix of kids who came from Algebra 2 Honors and kids that came from Algebra 2 Regular, and there's a big difference there. So there are going to be times in which maybe you were in Algebra 2 Honors and I'm doing something and you're like, oh my gosh, I've seen this a million times. I don't need to see this again. Never complain something's too easy, okay? Because then there's somebody sitting in this classroom that has never seen what you just did. So it's very different to come from Algebra 2 than it is to come from Algebra 2 Honors. If you were in Algebra 2 last year and I start teaching something and you're like, oh my gosh, I don't remember this at all, or you're in Algebra 2 Honors and that same thing happened, then I try to come up with something, because I can't reteach every skill from Algebra 2, but I try to find some supplemental stuff that can help you in those areas. So if you get into Canvas and you go to chapter 1, at the very top, there's a thing that says prerequisite skills, what should I know already? And it links you to a page. So these are topics that are going to come up throughout this module. So throughout from C1 to the end of chapter 1, you are going to get into, obviously we did graphing a coordinate plane, but we're going to get into graphing a line, simplifying radicals, multiplying, all that stuff. And in this list is factoring. I'm not going to reteach factoring, okay? But you have to be good at it. So if that is one of the skills that you know you need to work on, then sometime, maybe tonight, since you don't have an additional assignment, maybe tonight that's something that you go in and you either watch the video that goes through all the different types of factoring, or there's a PDF there for you to practice it. But in each of those areas, I tried to find an instructional video, either myself or somebody from YouTube going over that content, and then also a practice for you to try to catch up, okay? This is how you kind of level off the playing field, so that if you were in Algebra 2, you get to bring up your skill level. And if you were in Algebra 2 Honors, you just need the review, you don't remember whatever it is, then it's there too, okay? All right. Okay, this is question 1. So I would say overall, everybody did pretty good on question 1. A couple of things I tried to catch. I try to do a class kick before we do an assessment because there are things that if you just knew you were making a mistake on, you can fix them really easy. So 1 is watch your coordinate point form. If it's an intercept, if it's an x-intercept or a y-intercept, it needs to be in coordinate point form. So the x-intercepts are going to have 0 for the y's. The y-intercepts are going to have 0s for x. I might not take the full credit for that question, but I will dock you. So you got to be really careful with stuff like that. For your symmetry, there's going to be a little line that says x-axis symmetry, and yes or no. Y-axis symmetry, yes or no. Origin, yes or no, and you'll literally circle which one is yes or no, whatever it is, okay? In this case, it had y-axis symmetry, so this is one of those cases where at once I plotted the 3 points, I could draw it, and it was enough for me. I didn't need to draw anything else. This graph had symmetry to the y-axis, which is consistent with what we found for symmetry. So hopefully things like that help you out, okay? For the second one, this time, again, I did the x-intercept and the y-intercept. There was only one. When you get to the point for 0 equals x to the third plus 10x, this is what I'm talking about with the factoring. You got to take out the x, and then I would split and solve it from there. So once I take out that x, I would split and solve this into the 2 equations, and I get x squared equals negative 10, and I go to square root that, even with the plus and minus on the front, because that's what should be there. I'm square rooting a negative number, which can't happen. It's an imaginary number. So that rules out that one. We still have the 0 from the first one, so the x-intercept is 0, 0, which means the y-intercept is also 0, 0. But I want to check the y-intercept because it could be, you could have more than one y-intercept. So I plug 0 in for x, and I just also got 0, which means you only had 1 point. When you test for symmetry this time, it fails x, it fails y, but it does pass your origin symmetry test, which means anything that happens in that first quadrant is going to reflect down to the third quadrant. That saves you work, because if I plug in the point 1, I got positive 11, which means if I were to plug in the point negative 1, I would get negative 11. So we just change the signs on both of them, and it gives me my other point. I can do that without plugging in a point, because I can use the symmetry, or I can plug in a point and use the symmetry to confirm that it works, okay? If I had x to the third plus 10x, and I'm setting this equal to 0 to solve for my x-intercepts. You can't divide by x. If I divide by x, I actually lose a 0 because it cancels it out. You can't do it. You have to take it out. So you factor out the x, and you'd get x squared plus 10 equals 0. And then from there, I'm going to split and solve. So if I split and solve this, this is 1. X equals 0 is one of my x-intercepts. And then on the right-hand side, I'd get x squared equals negative 10. And when I go to square root that, I get the square root. It would be plus or minus, but I get the square root of a negative number, which is an imaginary number. We can't graph an imaginary number, so I rule that one out, okay? But if I had gotten, like, let's say it said x to the third minus 10x equals 0. How does that change things? What would be your first step? So if I add 10x to each side, I'm just like getting myself stuck in this loop, right? I'm going to take out the x. If I take out the x, I get here. Now what? Now I'm going to split and solve it. So I set them each equal to 0, and I get x equals 0, just like I did the first time. But now I get x squared minus 10 equals 0. Can I keep going with that? Yes. I'm going to add the 10. And I get x squared equals 10. Then what? Square root it, putting the plus and minus on the front. And I get x equals plus and minus the square root of 10, which is not a whole number. We would approximate it to be just a little bit bigger than square root 9, right? Which would be just a little bit bigger than 3. So I could say this is like a plus and minus 3.1 even when I go to graph it. So there'd be 3 intercepts with this guy. This is like a polynomial that does this, okay? But just know that you can't cancel them out. I can't just divide everything by x because I lose the x-intercept. That is 0, 0, okay? And obviously you can't solve when it's x squared equals a negative number, because when you square root both sides, it would make it an imaginary number, which you can't use. This one had origin symmetry. So the only point you got from your intercepts was your 0, 0, which means you're going to have to plug in extra points. If you had done the test first for origin, you're going to have to do it anyways. So you might as well check that first. The origin symmetry passes because all 3 signs changed, which means whatever happens in the top right over here is going to happen in the bottom right. or bottom left. So as soon as I plugged in 1 and got positive 11, I know that if I plug in negative 1, I'm going to get negative 11. I just reverse both signs. And then it saves you from plugging in another point. If you plugged in the other point, you would still get the negative 11. It's not that bad. But you've got to make sure that you get at least the 3 points in order to graph that shape. Yeah, Marcy. Okay, the last one also got a little bit messy, okay? So when you're finding your x-intercepts, you're setting this equal to 0. And then you cannot like take out an x. There's not an x on all 3 terms. So if you are still struggling with the factoring part of this, please make sure that you spend tonight reviewing the factoring, that little part of the prereq page, because hopefully you see this and you say, there's 3 terms, there's an x squared and there's an x, which means I have to factor and it's a trinomial. For me, I put it in order. It's preference. I put the x squared first. You don't have to factor it this way. I put the x squared first. And then when it's a trinomial, I'm looking for the factors of the last term that sum to the middle, which are negative 5 and positive 1. Then we split and solve this, and I get x equals 5 and x equals negative 1. That means there's 2 x-intercepts, negative 1 and positive 5. Then I want to find my y-intercept, so I just plug in 0 in place of the x, and I get y equals negative 5. So my y-intercept is 0, negative 5. Now that's a weird shape to take on as it is, but your prior knowledge of like parent functions, let's just say, tell you that if it's an x squared, it's a parabola. If it's a positive x squared, it's facing up, which means something is happening in between here, in between this point and this point, and I don't know exactly what that looks like. You can, at this point, estimate it, but you could also have just plugged in a point in between x being 0 and x being 5. Like if I wanted to plug in 2, let's say, then I would get negative 5 minus 4 times 2 plus 2 squared, negative 5 minus 8 plus 4, which is negative 9. So I would know that I'm like down here a little bit, and now I've got a better understanding of what this graph looks like. When I test for symmetry, it fails all 3. If I change just the y, it doesn't go back to the original. If I change just the x, there are 2 of them, but it doesn't go back to the original x. And if I change both, some of my signs change and some of them do not. That negative 5 did not change sign, so it would fail all 3 symmetry tests. All right, so we're going to start with WebAssign in 1.1, okay, which is the next section. So you're going to go to Canvas. You're going to click on the WebAssign link that says WebAssign PHA 2024-25. Even if you already have a WebAssign account, if you don't go this route, it doesn't know to put you into this class. So if you just log directly into WebAssign, it's not going to know that you're in pre-calc. You have to do this once. So you have to go from Canvas, click that link, and then take you to WebAssign, and then it will show up on your course list, and then you can go directly to WebAssign, okay? But you have to do it at least once. There's like future assignments on there. You don't need to do any of it, but there is a practice one if you want to work on it, okay? If you just want to get comfortable with the flow of it, you can wait to do this till tomorrow if you want, but it is simply just for practice. I would say that hopefully I'm consistent with what you did last year, but if you didn't do WebAssign last year, it could take a little bit of getting used to. This is where all of your homework's going to come from, most of it, okay? This is also where your ebook lives. So your textbook lives within WebAssign. My rule on WebAssign was the same as if you took Algebra 2 Honors last year, which is if you complete the work and you get an 80 or above, you get 100. If for some reason you get a question wrong or you skip it, that's when you're going to have that's when you're going to see credit lost. So if it's a question that I know needs work and you show no work, I'll dock the points. If it's something that you like turn in, like, and it's happened before, which is just nuts to me. Something's like a 40 on your WebAssign and there's no work. You just wasted a whole lot of time even trying to submit that. Okay, so that should not happen. But there are going to be times in which you get a question wrong because of the format of your answer. I don't need anybody stressing out about that. There's going to be times in which you have to graph, and graphing on WebAssign can get glitchy. Line's not so bad, but other things are annoying. You can simply take the picture of the graph just draw the graph on Canvas, on Notability or on a piece of paper. take a picture and submit it, and I will level back off that credit for your overall answer or your overall grade, okay? We'll talk about some strategies, like you can either screenshot the page, work next to it, or you can screenshot individual questions, work next to it, or you could split your screen. I don't care, as long as you carry over that work. And in the top right corner should be your score.